Thank you very much for the introduction. Sorry for my slides are in Hungarian. I was not aware that this is an English event. But anyways, I was asked to demonstrate our new platform, which is a robot dog that you can see here in the room from Boston Dynamics. We got the robot like 2 weeks ago, so it's also very new for us. And of course, even though this is just a demonstration section, I want to feature also our research. So we have some interesting research results that we want to use on the robot dog in the future. So let me just quickly introduce these other demonstrations that we have. It's about collaborative SLAM. So every user can wear such a device which has a camera and the IMU integrated. And with this, with several of these platforms, multiple people can be localized in the same environment. But for us it was very important not just to have a feature point cloud which is useful for robot localization, but also have a map which can be interpreted for humans. So this you can see in the middle row where the algorithm tries to identify the layout of a building. You can see the outline or the floor plan of a room. And here I have a video demonstration of the system. This was recorded with 3 such devices here in the corridor and in the next room, the chill out room of SZTAKI. And you can see the 3 devices after a small initialization. They are in the same coordinate system. And you can see that the entire point cloud is post-processed in the red rectangle. So it is interpretable also by humans. And the denser point cloud they are so-called image feature points reconstructed in the 3D. So this one is very useful for robot localization. So we intend to use this platform to co-localize humans and robots in the same environment, since we believe that for any kind of human-robot collaborative tasks, one of the first bottlenecks that we need to solve is to have a very reliable and precise co-localization. So also the human should know where is the robot, what the robot is seeing, and of course the other way around. For the robot is also important to know where is his master, let's say. And by wearing such a device, we can solve this issue to co-localize humans and robots in the same environment. Some other research tasks that we are tackling, mainly with artificial neural network, is the semantic segmentation of the maps that you could see previously. And we try to identify, of course, special objects in the scene. I mean, in this case, we are trying to identify doors and windows, and we try to segment once again the different rooms in the map. We call this kind of research spatial artificial intelligence. So we are doing we are also doing artificial intelligence, but our focus is on spatial understanding and how to apply these systems for vision-based localization and understanding of the environment. And if we go further, so as I told you previously, we want to put this system on the robot dog, and then in order to be able to co-localize hybrid teams of humans and robots. So this is briefly all of my presentation. And then we had a hackathon last week where the goal was to have a demonstration of the robotic platform. And we formed 4 teams, and the team that managed to win this hackathon was the one which had the goal to implement a handshake interaction of the robot dog with a human. So in the next step, we can demonstrate this. So I need a volunteer from the audience who is not afraid of robots. Will not bite you. Yes, please come ahead. And then my colleague will launch the demo. So we had 4 different teams. The task of the first team was to develop a simulator for the robot dog. they managed to have, let's say, an MVP, a minimal viable product. So they managed to install and use a simulator. Then, of course, the winning team was this with a handshake. So maybe we can start the yeah, please go a bit closer to the platform. Yeah, so this small demonstration is actually not using any images. It just notices when a hand is there. So it's based on a force feedback. So he can feel that there is a force applied to the joints, and until you don't. This is just to show you like what can we do in one day development. So this is our first little demonstration. But of course the platform is here for the community, so we are open for collaborations. We have also other ideas what kind of demonstration to and what kind of research to do with the robot. I showed you one little scenario previously, but we also want to teach him to understand Hungarian language. So that's our next goal, to have a large language model, and of course by using the large language model we want to have a demonstration in which you can just say, hey robot dog, please bring me the water bottle from the table, and from here on it should execute this task autonomously. So yeah, I think I finished a bit earlier than my time, but we can do the demonstration once again, or I have some more details about the collaborative localization platform that we have. Yeah, and yeah. Okay. Let me briefly, I have actually another presentation in which I have some more slides, but Andras tricked me a little bit. I was surprised that where are my other slides that I prepared, but yes, I have two versions of the presentation, so the presentation can continue now. So we actually analyzed all the papers that had in it the keyword quadruped robot, and we find almost 2,000 papers with this keyword, and the goal was to identify research gaps. So here you can see a visualized processing of all the 2,000 papers, and this is kind of the main research themes that we want to tackle with this new platform. So of course specific domain application. This is more for the applied research and for European projects. Of course, as I already showed you, the locomotion and the SLAM research that we do, we want to demonstrate with this new platform. And also with this SZTAKI blue, you can see some other related fields that we don't have yet results, but we are planning to do research in the future. So one is the human-robot interaction, for which we have the colocalization framework. And we also would like to tackle some neuromorphic or biologically inspired robotic research, especially together with the Pázmány Péter University. And yeah, so these are the slides with the hackathon. This was our schedule. One of the purposes of the hackathon was to have the development basics, so to have a common development infrastructure. This actually took almost half of the day to have everything on everyone's laptops, and then the development actually started around lunch or just before lunch, and we had a pizza dinner. This is a good practice. It was the first time that we tried to organize such an event where several of our colleagues were co-developing software for a specific task, and for us it was a very good experience, and I would recommend also to other research teams to, if they have the opportunity to organize similar events. Here you see some snapshots, and yeah, some other so the first one was to the first goal was to have a robotic simulator of the spot robot. We didn't finish here our development, but I hopefully in the upcoming weeks we can have some results on this. The main problem is to transfer something that was learned in the simulator, to transfer the learned task to the real platform and to execute it on the real platform. As I previously mentioned, we want to have a demonstration where we have the spot robot can handle a conversation in Hungarian, and here of course the speech to action is important, but also from a computer vision perspective we want the robot to identify a very important person, a VIP, and then have a casual chat with this person. And also another interesting thing for us was that some examples which are already there in the Boston Dynamics example libraries are actually very old demos, and they were not working out of the box. So one of the team had the task to download such a demonstration and to install it on the robot. The goal was to detect and identify an object, and then the robot should follow this object, like for example a human. But then we noticed that the neural network that was built, the entire demonstration was built around this neural network, was a very old one, and the buffer of after 10 seconds was full, and actually so basically the demonstration worked only for 10 seconds. So we were very much surprised that even this example code, which should work out of the box and is provided by Boston Dynamics, is actually not working out of the box as we planned. Yeah, so now my presentation is really over, but we still have, I think, 7 minutes. So if someone else wants to try the handshake demonstration, we can do it again. If not, then yeah, I'm happy to take questions. Yes, go ahead.
I'd like to know more about the variable sensor. So how is it communicating with the rest of the system?
It needs to be.
What's the processing unit inside?
Yeah, so it needs to be in the same Wi-Fi network. So that's the limitation of the system. And it's an NVIDIA Jetson inside. Yeah, my colleague Shanya can give you all the details. Okay, then thank you again, and I think we can continue with the next demonstration.